This is going to be a little bit of a quick video today. Since NetBSD 7 supports the Raspberry Pi 2, why not give it a try? So in preparation, I wrote, like it's some sort of CD. I wrote the image to a micro SD card for NetBSD, and I edited the command line.txt file there, so the boot configuration to turn off the frame buffer for the console. So it should default to the serial console. I'm using a USB to 3.3 volt serial converter connected up to the Raspberry Pi 2 to function as the console. Let's take a look. Let me start my taking a look at the serial device here. And I'll power up the board. So far, so good. And this is nice. It automatically grows the file system. So the image was about 1.1 gig, and I'm using a 16 gig micro SD card. So it's growing the file system, which is nice. I remember looking at this a while back in the 6.1 NetBSD, and you had to perform these steps manually. So that is a nice touch to do the automatic growth. Let's take a look at some of the boot messages while we wait for that. See if there's anything noteworthy. Obviously, it's got the disk. It is connected via Ethernet. It's gonna, I think, pull by a DHCP. So we'll have to find out what the address is, and we can secure shell into it. But so far, so good. What else can I talk about? Well, if you don't know, I'm sure if you've been living under a rock, Raspberry Pi, tiny little, very inexpensive single board computer based on an ARM system on a chip. I think this is from Broadcom, and since the success of it, so it kind of led the way. Also with the Beagle board and the BeagleBone, which I think the BeagleBone Black is a better platform for doing a lot of embedded stuff. You get a lot more GPIO. But that's just my take on it. And if you need performance, there are things like the PCDuino. Again, they're all very, very similar. One of the things I was noting when I was taking a look for this is NetBSD also supports what they call evaluation boards. So, little single board stuff in the MIPS family, and that's something I want to take a look at. I think it's just 32-bit MIPS, but the MIPS architecture is a classic. So maybe I'll try to get my hands on a MIPS evaluation board and see what's what. So the one drawback of doing file systems on SD cards is, I guess the fastest ones are 90 megs a second, which is not huge when you're talking in gigabyte size files. So that's kind of, I think, the bottleneck here. I mean, this is a 4-core CPU running somewhere around a gigahertz, but the storage is slow. I wonder if it's possible. It should be possible to put file systems off onto the USB. So I don't know if it's USB 2 or 3, but if you put the file systems off on USB, you may get a boost in performance, especially if you put a spinning disk on there or fast flash memory. While this is wrapping up here on the file system growth, what else can I really say about this? One of the things I'm going to do with this is try to build a kind of a mini pocket firewall, right? So use the firewall capabilities. I would have loved if OpenBSD was available. NetBSD will work. You can use their firewall software, which won't be a problem. So it'll be the Raspberry Pi 2 using one side of its built-in Ethernet, and then using a USB Ethernet adapter on the other side. And I like using the serial console here. I mean, one of the things I do need to pick up is a capture card. It's one of the things I've been greatly missing. Is a capture card, because some classic stuff that outputs RGB or composite. It'd be great to record off the real classic hardware rather than just say look at an emulator. And also for this, so, to get one that can capture HDMI. The other fun thing to do with something like this is that you can make cool retro things using emulation or even not emulation, but is to do a bundle this with a monitor, mouse, keyboard. You've got an X term. And currently my X term is an old iMac G5, but toss $100 monitor at this thing and you've got a decent little X term, or throw the TME emulator or QEMU and you can be running classic Sun OS 4, and that would be fun and clever, not terribly useful. So let's see, we've booted up here. Almost. Message of the day. So you can see it's not the speediest thing in the world, but decently fast, and I think it'll be fast enough to run a firewall, certainly at whatever I need to pass through it, maybe 20 or 30 megabits per second. It should absolutely be functional. And one of the reasons here is you're out at a hotel and you want to bring a firewall along with you for their plug-in network. Okay, and we're in. Let's take a look at the file system layout. So boot is probably going to be that VFAT file system here. So MS-DOS file system. You just get a root file system, but this is nice. So you can add some USB devices and toss that on there. So one of the things to do is we're going to set up the package path. I had to switch over here. I pre-prepared the package path, so we can do this nicely. So let's throw Emacs on it, just for fun, because on your pocket firewall you need Emacs. So that may churn on that for a while. Let me put that in the background. Let's try to get in via SSH. So we're 37. Just add a user here. So we can get in, because I'm sure out of the box root logins via SSH will be blocked, as they should be. That is, I have some gripes about that. Out of the box, maybe not, because you're doing a net install, you need to get in. And we're in. So that is that's pretty nifty. Let's see what the system's doing. So yeah, I mean it looks like it's doing a bit of I/O wait. Bring that back to the foreground here. So yeah, Emacs was probably the wrong package to throw in, because this probably needs a lot of, I don't know, GNOME or whatever to go out there. Take a look at the boot messages here. Now we can do some scrolling. So 4 cores, 600 megahertz. I don't know. I wonder if there's a way to overclock this thing. And one of the big advantages for the Raspberry Pi is it does have good graphics capability. So you have a nice frame buffer attached, which I'm not using here, connecting via serial. Um, don't have too much else to say at this point. I do want to get Emacs installed and make sure we can edit files. One of the things I've noticed, and this is a deficiency of package source. Now I know Elvis is not in the FreeBSD port system last time I checked. It is here, but there are some issues with Elvis, and maybe that's just my environment. That is my favorite editor, and maybe it's time to do a video comparing editors. I was really hoping that to eventually delve into some of these controversial topics, and nothing should stir up controversy like ranking editors. But I think my top five would probably please most people, or at least both sides, right, of that debate. So let's see what's in the boot file system while we're waiting on that. So there we have the command line.txt, and when I mounted the SD card, edited this on that file system. To remove it, had setting console equal to frame buffer. So that defaulted the console off to the serial port. And you see here you can set the frame buffer mode. And we get some arguments here. The bootloader. So it really is churning along. It's a little slow to install a package, but I guess Emacs was a pretty big package. I don't necessarily want to bail out at this point. So the other thing I don't know if the GPIO stuff is in here. Now I have no idea if this is the right GPIO, but maybe it is. This looks embedded-y to me. Doesn't seem like this is something you'd use on a general purpose machine. So perhaps it has the GPIO libs. It certainly has the header here. So I mean that's the other application of these little single board computers is you can have fun, connect stuff to them, do tasks. And if this works out, I may use this as a basis because this should have audio connections as well. And so one of the projects I'm working on is some amateur radio gear. I'm an amateur radio operator, and doing some stuff there. And right now I'm using what is it? A TI microcontroller to do the setting of the DDS and controlling the display and reading the rotary encoder for the tuning knob. But this may be nice to mix down to a kind of a low IF and then use the digital signal processing capability here in the CPU. So read the audio. So read, say, call it a 20 kilohertz block of the spectrum. So mix down to that low IF on with your main oscillator, and then use a little bit of digital signal processing to do the demodulation. I do apologize. This video is stretching out because, stupidly, I have said let's install Emacs, which is apparently a big package for Raspberry Pi. I'm using a Class 10 SD card here. It was the only one that Target had. So it should say micro SD card. It's a Samsung Evo. It claims it's Class 10 and fast. But again, even a Class 10, I think, what's that? 45 megs write, 90 megs read. That's pretty, for a modern system, that's pretty slow. Even, I'm trying to remember what my old Octane 2 workstation had on it. That was from what, like early 2000. I think that had 160 drives. So again, you get to hear me drone on a little bit more. I mean, that's what all these videos are, is me droning. You may learn something, get my opinion at any rate, point out where I screw something up. And I'm pretty new to this Raspberry Pi stuff. and that's why I'm happy that NetBSD is available. I think FreeBSD is also available. For this, OpenBSD is not, at least not in their kind of production release or stable. At least to my knowledge, I may be wrong there. Um, the other one I'm going to try out is Slackware. Just because, as you know, I'm a Slackware aficionado, and that may provide a little bit more access to software. But you're not going to be doing any commercial software on the ARM stuff, or very limited, right? So there's less reason to stick with Linux, um, especially because the BSD should have a lower overall footprint. I know in the x86, x64 world, you can have you know, a NetBSD image, and 100 megs a disk, and run it on 32 megs of RAM. It can be a very, very small system where, yes, you can do that on Linux, but it may be a little bit more heavyweight. And goodness, this is slow. I mean, leave a comment below if you have any suggestions for things to do with a Raspberry Pi 2. The other thing I'm going to be uh, picking up hopefully soon is Avnet. They're an electronics distributor. They've come out with a new FPGA board. Now, I love FPGAs. They're so much fun to play with. Programming hardware in HDL is just a treat. I find it a challenge, and it's enjoyable. And so I have some stuff, but I don't have any of Xilinx's what they call the 7 series, which are their latest. So you have the Vertex with those really high end, multi-$1,000 FPGAs. The Kintex and the Arctics, and of course the Zinc, which has an ARM core and then programmable logic. But Avnet and Digilent, and they're kind of an educational um, vendor. So Avnet has recently come out with a under $100 um, dev board that has an Arctic 7, and that's got about 35,000 logic cells, which is pretty big. And some of the cool stuff you can do with FPGAs is actually fully or almost fully recreate classic hardware. So people have done PDP-8s, PDP-11s, old Z80 CPM type machines. And unlike a software emulator, these are as close to being the real deal as possible, because they actually are. It's a hardware emulation. It's a hardware copy almost of the logic, and so they're pretty neat. Um, Again, I don't know if this is an issue or not. Why it's taking a long time. I keep trying to scroll here in my serial window, and that's I'm using Screen. Maybe I should use Minicom, but I kind of I have mixed feelings about Minicom. I used to use it a lot, way back in the early days of Linux. It was one of your the terminal programs. Again, for terminal program excellence, I always liked TIP on Solaris. TIP was nice. TIP was good. Um, oh no, I don't want to do that. Well, this looks like it's chugging along pretty well, and it is installed. So let's see if Emacs works. Hey, we got Emacs. Well, let's just do a little C code. So, wonderful Emacs C seems to work here. Let's see if the C compiler works here. Okay, well, I guess that kind of wraps it up. There may be kind of part two as I get into more of the setup or playing around with some different stuff. See if the GPIO, if this header is actually lets me do some GPIO out of the NetBSD stuff. Maybe take a look at FreeBSD on here, using their packet filter versus NetBSD's packet filter for firewalling, or maybe throw an emulator on it. I guess that's it for now. Sorry, this is more of a ramble. Didn't get to see much. It was just me talking while we waited for slow SD card. Um, well, thanks for watching. Please comment below if there's anything you'd like to see, talk about, criticisms, etc. Thanks.